It's super exciting for me and for our team to bring to you this technology that we'll introduce to you today. Before I get to that, I have to read you the safe harbor statement. The Genexus system and its assays are for research use only. Content of the presentation is based on future potential developments and intended to be entirely future-looking in nature. Thermo Fisher is not promoting or encouraging any current diagnostic or clinical use of the Genexus system or any research use only products discussed in this presentation. Okay. So as what you've heard today is the ideal system for a real broad spectrum of labs is something that delivers results in an incredibly fast time, ideally much less than the current 1 to 2 week turnaround time for in-house testing, or even 2 to 4 week turnaround time if you're going to external testing laboratories. It provides something that's easy to use, easy to train the technicians in the laboratory, would handle low amounts of samples or low numbers of samples cost effectively, and be extremely parsimonious on saving tissue and being able to test those samples very quickly. So we're really excited after 3 years of a huge amount of effort by our development team, over a few hundred engineers and software and scientists, to bring you the Ion Torrent Genexus system. It really is a turnkey, automated NGS platform to deliver the capability to offer specimen to report workflow in a single day turnaround time with only 2 use of touch points. And that gives you the ability to provide results from different testing modalities like immunohistochemistry and molecular profiling at the same time point. The two systems you'll see, the one on the left is the automated sample purification and quantitation system. And then the second instrument, the larger one on the right, is our automated library to clinical reporting or reporting solution. The system is manufactured with the capability for us to go to IVD approval, and we intend to seek regulatory approval for both the platform and the assays I'll describe a little bit later on. It is a general purpose sequencer in the sense that it can run multiple applications. Obviously, we're going to focus heavily on oncology and inherited disease, but reproductive health and infectious disease opportunities will come in the future. So a little bit on the workflow. At the front end, the purification system, which is coming in the second half of 2020, can handle a variety of different sample types that are common in the laboratories that we're talking about today. So FFPE tissue, plasma, bone marrow, or whole blood. It's a magnetic-based extraction purification system with full automation, cartridge-based reagents, 5 minutes of setup time, and a 2-hour workflow. And handles up to 12 FFPE samples or 6 plasma samples in a single run. Out of that will come 2 plates, an archival plate of nucleic acid for you to store, and a working plate of quantitated nucleic acid that will be the start point for the integrated sequencer workflow. The integrated sequencer itself has a number of really cool innovations that we're excited about. The first of which is the chip that you can see. We've now broken the chip up into lanes, so each lane can be addressed individually. There are 12 to 15 million reads per lane. We've also incorporated fully automated library preparation for both AmpliSeq and AmpliSeq HD library prep, and that can handle up to 32 libraries or 32 samples per run. The system goes fully through the automated template and sequencing process and library generation in as little as 14 hours for a single lane. And depending on the assay and the configuration of those assays, it could be as little as 24 hours to about 30 hours for a full chip run. So really can do a single day or even less workflow. The integrated sequencer is going to be available before the end of this year. The software itself is a brand new construct for the first time since we launched the original Ion Torrent PGM system back in 2010. It's a fully integrated workflow enabling specimen to reporting, so it integrates both our run setup as well as run monitoring, and then going into our Ion Reporter annotation, and then connecting to our Oncomine knowledge-based reporter to produce a simple report like you see on the right. A lot of effort has gone into simplifying the user experience, and making sure that we are comparable in performance in terms of benchmarking and variant calling accuracy to our existing systems. The software will track all the sample metadata from the beginning of the workflow to the end of the workflow, and also provide options to view the reagents that were used on the system. Each reagent is tracked on the instrument as it goes through the setup process to make sure that it is qualified and is in the right position so the user cannot make any mistakes when they are setting up the platform. In terms of flexibility to run assays, you can run up to 4 different assays at the same time. If they are the same chemistry and have the same thermal profiles, you can run DNA and RNA assays simultaneously. As I mentioned, we can multiplex up to 32 library preparations in a single run. If your assay, your AmpliSeq or AmpliSeq HD assay is a single pool, it's 32 samples. If it's a 2-pool design, it would be 16 samples. We've tested right now up to 2-week on-instrument stability, and we expect that we'll be able to increase that to about 4 for a standard laboratory temperature. So you can use lane 1 on day 1 or week 1, lane 2 on week 2, lane 3 on week 3, and potentially up to lane 4 on week 4. The assay flexibility is enabled by the colored strips. Each of them are very easy to place on the deck of the instrument. It's literally a 5-minute setup for the integrated sequencer itself, and we've minimized all the consumable footprints to make sure that it will fit in your precious freezer space. In terms of batching, we've made a huge effort to make sure that we can run the system effectively or cost-effectively at the low numbers of samples and have the flexibility to go to high numbers of samples. So compared to our current GeneStudio Chef platform, we anticipate that you'll have about a 50% lower cost per sample at a batch size of 4 on this system, and even running batches of 3 or 2 or even 1 is going to be significantly less expensive for you compared to the current platform technologies. So what about the assay roadmap? At launch, we've tested a variety of different assays, including our custom AmpliSeq and custom AmpliSeq HD assays, so assays that you've designed in-house that can potentially run on the platform. We've also tested our inherited disease portfolio for Ion AmpliSeq on demand. And we've tested through 3 specific Oncomine assays, a brand new assay we're calling Oncomine Precision. This is an AmpliSeq HB-based assay that will test both FFPE and liquid biopsy samples, so it's designed for both sample types. A little more about that to come. We've also tested our existing Oncomine Comprehensive Assay V3 for somatic variant detection performance, and our long read capability in our Ion Oncomine TCR Beta long read repertoire sequencing assay that requires up to 400 base pair sequencing. As we go through 2020, we'll add more assays to the portfolio, including our myeloid, our BRCA, and there's more to come, our Oncomine Comprehensive Plus, which you'll hear more about today, and some of our, as well as our Oncomine tumor-specific assays, which will be coming up in later sessions of this workshop. So how fast can it be? In the red box, what I'm showing is the run time as well as the number of samples for a particular run for the 2 variants of the Oncomine Precision assay, either for CFTNA, in other words, a liquid biopsy workflow on the top of that red boxed area, or the FFPE assay below. So if you're running a single sample per lane in the Oncomine Precision assay liquid biopsy workflow, that entire process would take you about 16.5 hours. For 4 samples across the whole chip, it would be 22.5 hours. The corresponding FFPE times would be 16.5 hours for 3 samples and 28.5 hours for 12 samples per run. So incredibly fast turnaround time, very simple to set up, very simple to use. A little bit more on the Oncomine Precision assay. A highly curated pan-cancer content. It's a 50-gene assay covering all relevant mutation types, CNVs, fusions, including RET, as you've heard today, as well as some tumor suppressor coverage and driver and resistant mutations. Designed to work on both FFPE and liquid biopsy, uses molecular tagging, and has a novel fusion detection approach we're calling fusion sync detection technology, as well as our current targeted isoform detection methodology. This is the gene content. You can see it covers a wide range of different targets in terms of intragenetic fusions. The ones in bold are the ones that we will have this novel fusion detection capability within, so including things like NTRAX, FGFRs, as well as RET and ALK, along with a vast expansion of our targeted isoform fusion content, by curating all the latest literature and getting that information into that in a very sensitive detection. A couple of examples of the data. On the left, you can see a concordance study against FISH and IHC for the Oncomine precision assay on the Genexus platform for 24 non-small cell lung cancer samples, FFPE samples on the left, both 100% concordant. And on the right is an example of detecting a RET fusion bias, new novel fusion exon tiling imbalance method. So what you're seeing there on the right graph, the blue line is the individual expression reads across that region as we're tiling across the RET fusion. And the gray are the normalized expression for wild-type RET. So what you can see in the red bar is where we predict the breakpoint for that fusion event to be, and predicting that the kinase domain is actually present, and therefore it's a functionally oncogenic protein. And we'll give you an imbalance score in the little table below, as well as a probability, a p-value threshold that we really believe that fusion event is real. Lastly, to cover performance comparison on Oncomine Comprehensive V3, this is run on the Genexus assay. The performance in terms of sensitivity and specificity, both inter and intra-run reproducibility, is really as good as we've seen in our current Gene Studio platform, so of a 98 to 99% sensitivity and positive predictive value with high inter-run reproducibility. So we're highly confident that the Genexus platform is going to be a great tool for you and provide you the ability to get single-day results or less with this platform. If you want to come and see more, please come and see us at booth 2825. I'm now going to introduce Dr. Jose Costa, and he is going to tell you he was one of our early testers and will give you his experience of using the platform in practice. Thank you for your attention.